First, I want to show you the first job that we ever saw with a pop-up. This water closet is in a 42-story building in Hong Kong. This went on for 2 years. You would see this trap start to bubble, gurgle, and then it would discharge so much that it would actually spray the ceiling. Now, yeah, and what would occur was that these individuals were actually taking sandbags and putting on their toilets. It would happen twice a day, in the morning when everybody got up, and in the evening when everybody came home. So, I mean, this went on for almost 2 years. They first thought that they had missized the vertical stack because it was a two-stack system, a waste stack and a vent stack system. So the waste stack was increased to 6-inch, thinking that, okay, it was too small. It made it worse. Why? It added more air to the system, okay? So that became a real problem. So what we did, we went in and installed 4 of our Papa devices in a row and solved that issue. I can very well imagine. You didn't pay for the bidet, but you got one.
That'd be quite a morning waker-upper.
All right, here we have a discharge into a vertical stack from a toilet. Okay, as you can see, it's obviously reached terminal velocity, and now cascading, the air is no longer cascading down the pipe, but it is swirling along the edges of the pipe. Here we have a traditional vented system, and as you can see, you're losing a little trap seal here. Why? Because it's the time response that the vent is having to go through to meet this need that is occurring as this transitions past this.
Is that just overcoming the inertial rest of the air in the vent system?
That's correct. That's right. It's having to move that air from the top of the building, which could take up to a second and a half, depending on the length of the building or how many floors up it has to respond to that, sir. Okay? So now we continue on till we reach the base of the stack. Now when we reach the base of the stack, you'll see this curtain wall form. Now this curtain wall that forms, it varies in size and in intensity according to the type of material that's in it. Swaffield and his staff has taken numerous pictures of these walls, curtain walls forming, and it's amazing whether it's urine or whether it's hot water or whether it's cold water or soapy water. These curtain walls vary, they change. But as you can see, what happens is that the air that's trailing now becomes sonic and is now traveling back up. And as you can see, only a small portion of that shock wave is traveling up the relief vent. Again, energy following the path of least resistance. Okay? So, the Papa, you have the same issue occurring. The water is discharged. It reaches terminal velocity. Now we've reached the branch, and you notice that we're not losing trap seal. The air admittance valve is responding within 0.2 of a second, protecting the trap seal and allowing only the amount of air into the system that's required. No more, no less. As it transitions down the vertical stack, you'll notice the same thing occur. Nothing changes here. But what happens here is that the Papa device attenuates the shock wave from 1,057 feet to less than 40 feet per second in less than 2/10 of a second. And that's how that works.
I have a question for you.
Yes, sir.
If the energy in the sonic air, the returning air, rebounding air, is following the path of least resistance, how is it that the PAPA device is able to relieve the shock since it's on a branch line?
That's a really good question, and I have a really good answer for you. Let me show you. All right. What happens is that device has two pipes running up through it. Okay, so that bladder, which is inside there, actually can never touch. Okay, so as the air travels by this, it creates a negative pressure inside the bladder. Okay, now you have negative pressure formed inside there. Now you have a partial vacuum, if you will, inside there. Now as that shock wave travels up, nature abhors a vacuum and it becomes the path of least resistance. That's what I thought. I said, how simple is that and how brilliant.
There would be some sizing, though, correlation there between the amount of displaced air in the vacuum and the amount of air slug coming down. I mean, it will only be able to absorb if you have a huge air mass that's bouncing back up and a certain restriction on the volume of your vacuum. Some of it will still go up the stack once you've repleted your vacuum.
Well, what happens is, and they've discovered, is that they have experimented to know that by taking and sizing this the way it's sized, that they size it according to the floors that it's serving. Mm-hmm. For example, on a 10-story building, you would only have to have one at the base of the stack. On a 15-story building, you would have one at the base of the stack and one midway. Now, one of the things that you have to remember is that in a drainage waste and vent system, that the discharges are chaotic. There is no way of measuring or knowing when and how they're going to occur. So you must make worst-case scenarios available. So what happens, and they discovered, is that if you have discharges in between floors, that you can actually get shock waves forming off the discharges, because it acts just like a change in direction. So that's the reason you will have one as the floors go up. So you'd have one at the base of the stack in a 10-story building, one at the base of the stack in a 15-story building with one midway. In a 25-story building, you would have one at the base of the stack, one every 5 floors. Then as you exceed 25 floors, you would have one every 10 floors, up to 50 floors. After 50 floors, then we refer back to Harriet Watt for additional instruction. But this will be an engineered system, and that's the way it's formatted. So at the base of the stack, we have a relief vent. Okay? We have the P-trap here. They've discharged a water closet in a simulated 20-story building, and as you can see, the shock wave blows it out. Now what we're going to show you is we're going to remove this plug, put a piece of plastic over the top of this plug to show you that the shock wave actually is moving through this system.